Hello friends, welcome to Bindu Dhadwal chemistry lessons. This is the third video for solving the questions of first chapter of NCERT Class 11 basic concepts of chemistry. Molar means 0.5 moles in 1000 grams of solvent. 0.50 molar means 0.5 moles in 1000 milliliter of solution. Molar means 0.5 moles in 1000 milliliter of solution. Now 0.5 moles means mass will be 53 grams. So from 1000 grams of solution you subtract 53 grams to get mass of solvent. So 0.50 mole will mean 53 gram of solute. So 10 volumes of dihydrogen gas react with 5 volumes of dioxygen gas. How many volumes of water vapor will be produced? So we write the balanced chemical equation. 2 moles of hydrogen plus 1 mole of oxygen forms 2 moles of water. So when 10 moles will react, that is 10 volumes. Next question is convert the following basic units into basic units. 28.7 picometer. Now 1 picometer is 10 raised to power minus 12 meter. You simply multiply the 28.7 with 10 raised to power minus 12. 15.15 microseconds. 1 microsecond is 10 raised to power minus 6 seconds. So you multiply with 10 raised to power minus 6. 25365 milligrams. To convert milligram into kilograms, you have to multiply with 10 raised to power minus 6. Next is which one of the following will have the largest number of atoms? 1 gram gold. You know that atomic mass of gold is 197, so 1 mole makes 197. 1 mole contains 6.022 into 10 raised to power 23 molecules. So the number of atoms in 1 gram will be 6.022 into 10 raised to power 23 divided by 197 gram Na. You know 23 grams is 6.022 into 10 raised to power 23, so 1 gram will have divided by 23, 2.6 into 10 raised to power 22 atoms. 1 gram lithium divided by 7. So you get 8.60 into 10 raised to power 22 atoms. 1 gram of chlorine. Now 1 molecule has 2 atoms. So 1 mole or 71 grams will have 2 into 6.022 into 10 raised to power 23 atoms. And to get in 1 gram of chlorine you divide by 71, so you get this answer. Of these, this is the least lithium, so 1 gram of lithium has the maximum number or largest number of atoms. Calculate the molarity of a solution of ethanol in water in which mole fraction of ethanol is 0.040. Assume the density of water to be 1. So mole fraction XB will be number of moles of B upon total number of moles. Now number of moles of ethanol is given 0.04. So 0.04 is equal to NB upon number of moles of water plus NB. Now number of moles of water will be 1000 upon 18. This is the number of moles of solute will be 2.31. Now 2.31 moles are dissolved in 1000 grams of water. So molarity will be 2.31 molar. Next question, what will be the mass of 1 C12 atom grams? So you know that 1 mole contains 6.022 into 10 raised to power 23 atoms. They will have mass 12 gram. So 1 atom will have mass 12 upon 6.022 into 10 raised to power 23. That is 1.993 into 10 raised to power minus 23 grams. How many significant figures should be present in the answer of following calculations? So you find out the term which has the least number of significant figures. So this term has 3, so the answer will also have 3 significant figures. In case of 5 into 5.364, we will give the answer with 4 significant figures. The exact figure 5 is ignored. In this calculation, we have this term which has the least number of significant figures, 3. So answer will be having 3 significant figures. Next is use the data given in the following table to calculate the molar mass of naturally occurring argon isotopes. So to find out, you multiply the total mass with the total number of atoms. So mass of this isotope will be its abundance multiplied by its mass. Then similarly for others, we add all the 3 up and divide by the sum of the abundances, which comes out to be 100. So on dividing, the answer comes out to be 39.947 grams per mole. Next numerical is calculate the number of atoms in each of the following. So 1 mole has 6.022 into 10 to the power 23. 52 will have multiplied by 6.022 into 10 to the power 23. We get the answer 5.13 into 10 to the power 25 atoms. Now 52 atomic mass unit. So 1 atom's atomic mass is 4. So 52 will have 52 by 4, 13 atoms. 52 grams. As you know that 4 grams is the mass of 1 mole of helium. So which has 6.022 into 10 to the power 23 atoms. So if 4 grams has 6.022 into 10 to the power 23, then 52 grams will have 52 into 6.022 into 10 to the power 23 divided by 4. This comes out to be 7.83 into 10 to the power 24 atoms. A welding fuel gas contains carbon and hydrogen only. Burning a small sample of 8 in oxygen gives 3.38 grams of carbon dioxide and 0.690 grams of water and no other products. And volume of 10.0 liter at STP of this welding gas is found to weigh 11.6 grams. Calculate empirical formula, molar mass and molecular formula. So we will utilize the different concepts to find out first the percentage composition. Then we will use the percentage composition to find out the empirical formula. Then again we will use the mole concept to find out the molar mass and calculate the molecular formula. So we know that if carbon dioxide, 1 mole of carbon dioxide has 1 mole of carbon. So molecular mass 44 grams of carbon dioxide has 12 grams of carbon. Then 3.38 will have 12 upon 44 into 3.38. This is 0.9218 grams of carbon. Similarly, water 18 grams has 2 grams of hydrogen. 0.690 will have 2.18 into 0.690 is equal to 0.0766 grams hydrogen. Total mass comes out to be mass of hydrogen plus mass of carbon equal to 0.9984 grams. Percentage of carbon will be mass of carbon upon total mass into 100. This comes out to be 92.33%. Similarly, percentage of hydrogen is 0.0766 upon total mass into 100. This comes out to be 7.67%. So using these percentage composition, we find out the empirical formula. The element has carbon has 92.33% composition. Hydrogen has 7.67% composition. So dividing by the atomic mass, we get the number of gram atoms, and dividing by the smallest number of gram atoms, we get the ratio 1:1. So empirical formula is C1H1. Now we know 10 liters of the gas weighs at STP 11.6 grams and 22.4 liters will weigh 11.6 upon 10 into 22.4, which comes out to be approximately 26. So you can find out this is the molar mass, so you can find out the value of N. N is molar mass upon empirical formula mass. Empirical formula was having 1 carbon, 1 hydrogen. Its mass will be 12 plus 1, 13. Dividing 26 by 13, you get 2. So molecular formula is 2 into empirical formula, which is C1H1. So 2 into C1H1 will be C2H2. So the gas is acetylene. Next question, calcium carbonate reacts with aqueous hydrogen chloride to give calcium chloride and carbon dioxide. According to the reaction, calcium carbonate plus 2 HCl gives calcium chloride plus carbon dioxide plus water. What mass of calcium carbonate is required to react completely with 25 milliliter of 0.75 molar HCl? So molarity, the formula is mass upon molar mass into volume. Then mass of HCl will be molarity into volume into molar mass, that is 0.75 into 0.025 into 36.5 is equal to 0.684 grams. So the mass of HCl we have calculated. Now from the balanced chemical equation, we know that if 100 grams of calcium carbonate molar mass reacts with 73 grams of HCl, then 73 grams reacts with 100, then 0.684 will react with 100 upon 73 into 0.684. This is 0.94 grams. Next question, chlorine is prepared in the laboratory by treating manganese dioxide with aqueous HCl. According to the reaction, 4 HCl plus MnO2 gives 2 water plus MnCl2 plus Cl2. How many grams of HCl reacts with 5 grams of MnO2? So according to equation, mass of HCl is 4 into 36.5, that is 146. Mass of MnO2 is 55 plus 2 into 16, that is 87. So 87 grams MnO2 will react with HCl 146. 5 grams MnO2 will react with 146 upon 87 into 5. So this comes out to be 8.39 grams.